right? Yes.
The inverter in exam need to write the NOT gate.
Write the what?
Can just write inverter, right?
Yeah. You can just write inverter or no gate. This one, and gate is A multiply B, right? You have, let's say in this case, 2 signal in. When you have 2 signal in, do you need to memorize this table? No, right? You can actually derive this table. How to derive? I got 2 signals, so I should have 1, 2, 3, 4, right? The 4 row. How to get all these 4 rows? Refer to the table given in the exam, right? So let's say the first one is 0, 0, 1, 0, 0, 1, 1, 1. This one no need to memorize. This one comes from the binary table I showed you earlier, okay? And how to get the output here? Just use the multiply concept, right? 0 times 0 is 0, 1 times 0 is 0, 0 times 1 is 0, 1 times 1 is 1. Okay? So you don't need to memorize the truth table. What you need to memorize is this gate, this symbol, this expression. And this 7 expression is quite straightforward, right? So OR gate, AND gate already have it. The next one is AND gate, right? With an AND in front, so it's an AND gate. AND gate is whatever multiply opposite. So the same input, 0 multiply 0 is 0, right? Opposite of 0 is 1. So you do need to memorize. 0 multiply 0 is 0, opposite is 1. 1 multiply 0 is 0, opposite is 1. So this one you also can derive it, okay? So after that is, you're already done with the AND gate. The next one is actually an OR gate, right? Same thing, this no need to memorize. And what you need to know is A plus B. A plus B. 0 plus 0 is 0, so you got 0. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 1, okay? This concept itself and this table, same as this definition. Only thing I want you to take notes of, the OR gate here, the symbol here look curved, alright? So after all, the next one is AND OR gate, right? Which is AND OR gate. Same symbol but with a little dot in front. So whenever you plus already, you take the opposite. Let's say 0 plus 0 is 0. Opposite of 0 is 1. 1 plus 0 is 1. Opposite of 1 is 0. 0 plus 1 is 1. Opposite of 1 is 0. 1 plus 1 is 1. Opposite of 1 is 0. So basically this table also don't need to memorize, right? So after this, the next gate is what? Is XOR gate. XOR gate, the front here has 2 lines, okay? This one you may need to memorize a bit. In this concept, it said the output is high when an odd numbers of 1 is applied to its input. Let us look at this example. 1 plus 0. 1, how many 1 I have here? 1. And this 1 of 1 is actually an odd number, right? So when it's an odd number, I should have a high, which is 1. The output is high when an odd number is 1 applied to its input. So this one is an odd number, this one is an odd number, so I got a 1. It's only when the 1 is an even number, then I got a low, which is 0. So XOR gate, this little symbol here, you have to remember, if I got odd numbers of 1, my output is high. If I got even number of 1, my output is 0. Okay? Same concept apply if I got 3 signal, ABC. If I got ABC, right, and if let's say my C is equal to 1 in this case, 1, 0, 1, then your output here should be 0 because out of the 3 signal itself, you have 2, 1. Okay? Same concept. This is how it's mean over this truth table. Okay, repeat, I draw. Just now I said the XOR gate, right? We have A and B, right? This one I got 4 rows, 1, 2, 3, and 4, right? If I have another C, I should draw how many rows? All the way down to 8, right? And this 8 number you can copy from the table. Let's say I just simply get one example, 1, 1, 0. What is the output here
How do you know?
for this row itself? Let's say this one is my output.
Okay,
I got 1, 1, 0. This one should be, if I have 1, 1, 0, what is the output here? If there's X OR gate, 0, right? Because it's a even number. So if I got 1, 0, 0, the output here should be 1. Same thing. Alright? So if I got 1, 1, 1, 1. Because 3, 1 itself is still an odd number of 1. So your output should be equal to high.
The output is not according to the table.
Okay? So the only thing for me, right, that you need to memorize is maybe the XOR gate and also X NOR gate. This one, the concept is opposite to XOR gate, which means that only even number of 1, I got a high. If an odd number of 1, I should have a low. That's all. By that, you have already memorized all the 7 gates. So gate 1 is inverter, 2 AND gate, 4 OR gate. The 4 OR gate itself, the first one is normal OR gate. The second one is the AND OR gate. The third one is X OR gate. The last one is 8 NOR gate. Alright? Can? It's not difficult, and don't spend your time to memorize the truth table. I want you to memorize the operation only. Okay? Then from there, you need to know how to draw the diagram, how to use the Boolean expression, or how to get the truth table. Let's try this one. Right? This is example. How many gates I have here? I got 3 gates, right? 1, 2, and 3. This gate, what gate it is? AND gate. This one also, and this one is an OR. So the first AND gate, the signal I got A and B bar, right? Means that in front here actually has an inverter, but we don't draw it. But what we have is A and B go through an AND gate, so it has to be multiplied. So over here, if I got a signal C, right, is equal to A multiplied B bar. The second gate here is actually also an AND gate. What I have is A bar multiplied B. So if I got a final output here as an X, right, I should plus these 2 because this is actually an OR gate. This is how I get the last one, A dot B bar plus A bar dot B. This is this is this. And we treat with a plus because this is an OR gate. Alright? So once you have this, if I need to produce a truth table, this is another example. So this example itself, I give you a diagram, you find the final operation. This one is, I give you an operation, I need you to draw the final gate. So for this one itself, you need to consider this as 1 gate, this one as another gate. So 1 gate, 2 gate, go all to the last one, so you basically have 3 gates, 3 main gates. Alright, let's look at this one first. A, B, C bar with a bar on the top. This one is this, or this one is this. I have this one, right? 3 signal, 1, 2, 3. This one should go to this logic gate. These 2 signals should go to this logic gate. And these 2 combined should go to this logic gate. Alright? Let's look at this one first. Let's say A dot B dot C. If you see A dot B dot C means it's an AND gate, so I got an AND gate, right? But the high, this all together, the top has 1 long bar, so it means that this is an AND gate with a dot in front. So this is an AND gate. This one is an AND gate with 3 signals in. Alright? The only thing is signal C is actually an inverter. So signal C should go through an inverter, become a C bar. So I got A dot B dot C bar go to this gate. This is what is meant here. Alright? So if I just give you the expression itself, you need to draw this one first. And the other one is A circle plus bar. I don't know what is this called. I call it A plus circle, right? B. And this one you know is actually the X OR gate, right? So X OR gate look like this. How many signal go in? 2 signal, which is A and B only. So I got A and B go in to this. And all this go into another OR gate because I got a plus sign here. So these 2 signals combine into 1, these 3 signals combine into 1, become 2 signals into the last one. Can? Alright? This one very easy to make mistake. Please try and practice it more at home because very easy. Sometimes you may confuse because of the bar itself. Alright? The last but not least, I need to show you this one. This one, in this type of question, right, actually are more likely to come out in the exam instead of the previous 2 because this one combine everything. Alright? So the following logic gates have the input waveform. How to read this one? How many signals I have? 1, 2, 3, 4, 5, right? And if you look at it, right, you know this is low, high, low, high, low. So it means that what? 0, 1, 0, 1, 0. Okay? So for the signal A itself, your truth table should have 5 rows. The first one is 0, 1, 0, 1, 0. For B itself, you have low, low, high, low, low. 0, 0, 1, 0, 0. So for column B itself, you got 5 rows. The first one is 0, 0, 1, 0, 0. Okay? This is how you convert this waveform into a truth table like this. So for signal A itself, you got 0, 1, 0, 1, 0, 0, 1, 0, 1, 0. Okay? If the question gives you waveform, you use the waveform. If the question didn't give you the waveform, you copy from the table I showed you earlier, the binary one. Okay? So once you have A, for B itself is 0, 0, 1, 0, 0. So it's 0, 0, 1, 0, 0. This is how you get A and B. Alright? After this, you look at each of these gates. First gate, second gate, third gate. So you need to come out the signal for C. Signal for C comes from A with an inverter, which means that whatever signal A, I have to invert it. So I look at A here. The first one is 0, invert. Opposite of 0 is 1. Opposite of 1 is 0. Opposite of 0 is 1. Opposite of 1 is 0. Opposite of 0 is 1. This is how I get C, because C is actually an inverter here. Okay? Right? Ken? What about D? What is this D? What is this D gate? AND gate, right? And this receive how many signal? Which is A and B, right? So in order for me to get D, I should have A multiply B, right? So I look at A and B. 0 multiply 0 to give me 0. 1 multiply 0, 0. 0 multiply 1, 0. 1 multiply 0, 0. 0, 0 is 0. Okay? And what about X? What gate it is? AND OR gate. It's an OR gate, right? It's an OR gate. But in front I got a dot. The other, the XOR or XNOR gate, the front part here have 2 lines. The OR gate is only curved. If I got 2 curves, means it's an XOR gate or XNOR gate. And this little dot here, every time is the bar on the top, so it means opposite. So I should have C plus D opposite, right? C plus D. 1 plus 0 is opposite of 1, 0. Right? So 0 plus 0 is 0, opposite of 0 is 1. 1 plus 0 is 1, opposite is 0. This one 0, opposite is 1. 1 plus 0 is 1, opposite is 0. This is how you derive the entire truth table here. And if I want you to draw this one in terms of the waveform, it looks like this. Because this is low, high, low, high, low. Low, high, low, high, low. So this waveform is referred to the X. Okay? Which means that if I have these 2 signals go into this gate, right, the final output look like this. This is how the logic gate works in this case. So in the electronics example, right, every time your controller, your PLC, he will receive all different signals, and you need to create your logic, and based on this logic, you will know that your final controller will receive certain form of wave. So sometimes it's open, close because of that. And that is the entire purpose of why we learn the logic gate and why we learn the binary system, etc. Okay? So, just times.
The example 2 is it, can show how to do the truth table.
Which one? Which example?
Previous one.
Previous one? This one? How to draw a truth table?
Yeah, is it even
How many signals I have? Never give the signal. No truth table? Because the question they ask you to draw a truth table, right? Oh yes, yes. That's why I said, if you have signal like this one, right? How many, the truth table itself, how many rows you should put? 8, right? And you have A, B, and C, right? So this and this become another signal. So you have A, B, let's say this one is B. This one is, let's say I put D, E, F. So the truth table itself, you have 8 rows. You have A, B, C, copy from the table itself, right? And then your B, you have to use this concept. Let's say A and B, if A is 0, B is 0, over here, you don't have any numbers of 1, right? So your answer should be 0. And same concept, same thing. Only when you have odd numbers of 1, then you will have the high, right? If you have even numbers of 1, you will have a low. Apply here also. Okay, understand? I had to draw a lot of things. Okay, let's try. Let's say in this case, actually we can use this example. Okay? Let's say over here, I put, let's say this one, I put here is D. Let's say this one is D. This one is D. Okay? Let's say this is D. First of all, how to fill in here? The first one should, what number should I put? 0, 0, 0, 0, 1, is it? Then 0, 1, 0. Okay, etc. Until the row A. The last one should be 1, 1, 1, if I'm not wrong. In between here, you fill it yourself. So in this case itself, this is an AND gate, right? This one is an AND gate, but it's actually an OR gate. But before you able to get B here, you must find the C opposite first. So let's say I got a C bar here, right? I need another signal, let's say C bar. So this one is always opposite, right? This one you will feel yourself. This is C bar. And for this gate itself, let's say I got here E. Let's say I put another signal E here. And this truth table, the E is actually have 3 signals, which is A multiply B multiply C bar. So I got A multiply B multiply C bar. 0, 0 multiply this becomes 0. 0 multiply 0, 0 becomes 0. Things like that you follow. So for this, let's say I put a E here, right? This should be the E. And then let's say I put a F here. You use the same concept to draw another side, the F. And then all these E and F, right? Let's say E and F go into here, you create another, let's say H. It's just another column there. So the concept are all follow the gate itself, and then the final, the truth table, the only important part is you must be able to draw this one out. Because I didn't give you the waveform. If I give you the waveform like this, you don't need to use these types of table. You just use the waveform that's given to you. Alright? Can? I think that's conclude all the topics for. So next week, when I supposed to start today's lesson for topic 3, control 1. We haven't do the revision for that, right? I'll do it next week also. And for next week revision, I will pay more attention to topics 1 and 2 because I expect you all forgot your topics 2 already. And topics 2 last time that you all do, right, the mass balance, right, is more on the first transfer function. In your final exam, you have more complicated transfer function. Alright, so please come for the next revision because I want you all to refresh your memory how to derive the transfer function for different things. Alright, thank you.